Okay, this is geotrig, lesson 5, day 3. We're going to continue with radicals, square roots mostly. And today we're going to introduce this idea that we could take square roots of fractions. Now, if you remember that a square root can be switched over to exponent form, then it really just becomes an exponent on a fraction. And if I have an exponent on a fraction, I can take that exponent to the top and to the bottom as a power, which means, that when you square root a fraction, you can square root the top and square root the bottom. So, the first thing I want to do is I want to separate those square roots. So I'm going to have 3 square root 3 over square root 2. Does everybody understand that the square root of 3 halves can be written as square root of 3 divided by square root of 2? Now, how did I know that that 3, which was on the outside, goes to the top and not to the bottom? How would I know this? Because it's over 1. You guys should remember that this is really 3 over 1, so that means it gets multiplied to the top. Very nice. So then it goes minus 4 square root 2 over square root 3. Would you guys agree? Okay. And then plus 2. Wait a minute. There is no denominator, or the denominator is a 1. But 24, square root of 24. Could I possibly fix that? Could I reduce that? Is 24, can I break that down? This is what we did the other day. That's 2 and 12, 2 and 6, 2 and 3, right? Do I have any partners? I have the 2 2's. They get to leave. So if they leave, they go to the outside and get multiplied. The 2 and the 3, which are left home, get multiplied back together, and it becomes 2 times 2 times the square root of 6. Is everybody following that? We did some of that a little bit in our heads. So the 2 times 2 actually becomes 4. That's nice. But here's the problem. So right now, we've broke apart the fraction twice. Simplified a square root. Awesome. So we're on our way. Now, if you remember things about fractions, we don't like negative exponents, right? That's something we don't like, especially when we have them in the denominator. We don't like fractions in the denominator. And we don't like square roots in the denominator. So you can't have a square root in the basement. And so now we have to, what we say, or what the mathematicians say, is rationalize the denominator. Which means get rid of the square roots, or even the cube roots, or fourth roots later on. To get rid of a square root, what do you have to multiply a square root by to get it to be a nice number? We've talked about this already, actually. Square root of 2 times this number will turn it nice. What would it be? You guys all know. If I multiply square root of 2 times square root of 5, what do I get? Square root of 10. Is that a nice number? No. That's not going to be a nice square. It's not a perfect square. So what number, when I multiply square root of 2 by, will create a square root of a perfect square? 2. Not 2, but actually the square root of 2. Square root of 2 times square root of 2 is what?
4.
Square root of 4, which is 2. The square roots will cancel each other out, right? They'll go away. But what I do to the bottom, bless you, I have to do to the top. Okay, moving on to the next fraction. I have this divided by square root of 3. So I'm going to multiply top and bottom by, not 3, square root of 3. Remember, when you multiply two square roots, you get to multiply them together. So let's simplify that now. What's 3 times square root of 3 times square root of 2? Well, the 3 I can leave up front. So it becomes 3. What's square root of 3 times square root of 2? Square root of 6. Square root of 2 times square root of 2?
4.
Square root of 4, which is 2. I got rid of the square root on the bottom in the denominator. Minus, what's the top going to be? 4 square root 6. All over 3 this time. And plus 2 times 2? Square root 6. Hey, this is kind of nice. Do you guys recognize that these are all square root of 6s? These are all square root of 6s, so therefore they all can be put together. Would you guys agree? No, you can't put them together unless you have a common denominator. What's the common denominator between 2, 3, and 1? 6. So, multiply the first fraction by 3. What I do to the bottom, I do to the
Top.
The second one, I multiply by 2. What I do to the bottom, I do to the last one, I multiply by what I do to the bottom, I do to the top. So therefore, now make sure, guys, you guys notice I'm putting these numbers in black here at the back, but they're not going to be multiplied to the number inside the square root. That is a coefficient that goes and attaches, I will say, to the number in front. What's 3 times 3?
9.
So we get 9 square root 6 all over 6 minus 8 square root 6 all over 6 plus 24 square root 6 all over 6. If I have 9 of something minus 8 of something plus 24 of something, what do I have? I will have 25 square root 6 all over 6. And that is your answer. So now we're going to move on to question number 5. Number 5, guys, number 5 actually should not be an issue for anyone. But what happens to be the issue is that people forget 2 rules. The first rule is that when you multiply a square root times a square root, you can multiply the numbers inside. We've dealt with that on the top one in number 4 and in our other problems leading up to this. The other one is that they forget that that's a binomial times a binomial and that you have to use the 4-letter F word, FOIL. So, 4-letter F word, FOIL. First, outside, inside, last.
Hey,
FOIL.
you know what I was thinking? I thought you were about to say.
So remember, FOIL stands for first, outside, inside, last. And so, let's put that to practice. And so, whoops, I turned the page. Here we go. So, we have to do square root of 2 times 1, which is 1 square root of 2, or just square root of 2. Square root of 2 times a negative square root of 2 of x. Sorry. So a positive times negative is a negative. And square root of 2 times square root of x is the square root of 2x inside the togetherness square root there, huh? X times 1? 1x. And x times a negative square root of x. Positive times a negative again is, and that's x square root of x. Guess what? That is done. You are done with that problem. It's not too bad. Now, of course, you should be able to look at this part right here and recognize that if that's the square root of x, that means that is x to the 1/2. And x times x to the 1/2, what should you do with those exponents? Or what could you do? What can I do if this becomes, if this becomes x times x to the 1/2, what can I do with those exponents, guys?
Combine
You
them.
combine them by,
1, 2.
it's like the first rule that probably on our exponent rules in the back of this lesson.
Addition.
By half.
The addition. You would add them. But because we have square roots and everywhere else, I am not going to do this right now, so I'll just take it out. You leave it because technically x times the square root of x is the most simplified version of a square root. So lesson 5, page 47, day 3, 11, 12, and 13. Have a great day.